So AI is no longer just theory, right? It's basically becoming the operating system for global infrastructure.
Absolutely, it's everywhere.
But that speed raises the big question. How do we make sure this whole revolution is, governed responsibly, that it's trustworthy and actually benefits everyone, every country?
That's the core challenge.
So today we're diving into the outcomes from the International AI Standards Exchange, fresh from the AI for Good Global Summit 2025.
Yeah, our mission here is really to deliver the blueprint that's emerging from that summit. We want to cut through the high-level talk.
Get down to brass tacks.
Exactly. Find out how this international collaboration is trying to turn abstract ideas like ethics and safety principles into something, well, practical, something governable in reality.
And the source materials we have, they cover a huge range. I mean, technical discussions on data center carbon footprints,
Hmm.
all the way to frankly jaw-dropping stuff like mind-controlled Formula One
It's a
cars.
massive landscape.
Okay, so let's start with the baseline. The reports are saying voluntary standards are somehow priority number one for global AI collaboration. Like, even above R&D funding or ethical treaties. Why put the rulebook first?
It does seem a bit counterintuitive, doesn't it? You'd think, let's build the cool stuff first.
Yeah.
But what's really fascinating is that leaders globally seem to get that standards are the essential operating manual. They're the necessary handshake that lets innovation actually scale safely.
The handshake.
Yeah, they provide
Okay.
this robust framework. It guides responsible development. It fosters trust, compliance, and yes, it actually enables innovation too.
So if it's the operating manual, what jobs does it actually do? What are the specific
Well,
roles?
it's got this vital dual role. First up, really crucial, is risk mitigation and trust.
Okay.
I mean, if you as a consumer or a regulator have no idea how an AI system was tested or measured or evaluated,
Yeah.
you're just not going to trust it.
Right. Makes sense.
So standards define those repeatable methods for testing. That helps identify and mitigate the risks when you deploy these systems, and it ensures they meet concrete criteria for safety, for reliability.
So the standards prove the AI does what it claims to do, basically.
Pretty much, yeah.
Yeah.
And the second role is facilitating the market and policy side of things.
How so?
Well, imagine if every single country had totally different requirements for AI. It would just grind global trade to a halt and make compliance impossible, especially for smaller companies.
Yeah, a nightmare for startups.
Exactly. So standards harmonize those requirements. They promote interoperability, making systems work together, and they level the playing field. This makes it way easier for startups and SMEs to compete globally. And, crucially, it simplifies compliance with all the different national laws that are popping up.
Which is happening fast. And you mentioned it's not just about function, it's the bigger picture, too. Sustainability comes in here.
Oh, absolutely. That was a huge discussion point, integrating sustainability right into the standards framework.
Because AI uses a ton of energy.
It's totally dual-natured, yeah. It's a massive energy consumer training models running data centers, the carbon footprint. But at the same time, it's potentially a powerful tool for climate solutions.
So standards help manage that paradox.
That's the idea. They're the mechanism. They guide developers in measuring and optimizing things like product efficiency, how data centers operate, network performance, resource
So
management.
holding the industry accountable for its environmental impact.
Basically, yes.
Yeah.
Minimizing AI's growing footprint.
Okay, that task sounds monumental, making standards for all of this. But if every country, every company makes its own rules, you just get chaos.
Hmm.
So how are these global bodies, the ITU, ISO, IEC you mentioned, coordinating? How do they avoid tripping over each other or creating conflicting rules?
That coordination piece is absolutely central. It's a huge challenge because the AI landscape moves so incredibly fast. You know, a traditional slow standards process just wouldn't work.
It'd be outdated before it was published.
Exactly. That's why a major focus at the summit was launching the AI Standards Exchange database. It's a big collaboration, ITU, ISO, IEC, IEE, IETF, all the heavy hitters.
Okay, that's a lot of acronyms. Sounds important, but is it just like a giant shared Dropbox folder? What's the real impact?
No, it's much more than that. Think of it more like a living, definitive library for global AI governance efforts.
Okay.
It's a one-stop gateway. You get access to over 700 existing AI standards, technical reports. The goal is coherence, technically speaking, and making sure solutions can work together. Interoperability.
And it organizes them somehow.
Crucially, yes,
Wow.
it doesn't just dump documents on you. It classifies them by industry like healthcare, finance, by the type of human AI interaction, by specific use cases.
So if I'm building, say, a medical diagnostic AI for Europe.
You can instantly find the relevant global standards that already exist. You don't have to reinvent the wheel or worse, accidentally build something non-compliant.
I see. So it makes fragmentation harder to excuse if it's all in one place. Now, you said the standards bodies themselves need to focus on 4 key things to make this work impactful. What were those, and how do they avoid just creating, academic exercises?
Yeah, the leaders on the panels really hammered this point. Impact means practical application. So 4 elements. First, translation.
Translation.
Taking those high-level ethical principles, the stuff everyone nods along to, and translating them into practical, measurable, executable standards, things you can actually build and test against.
Okay, make it real.
Second, structure. Systematically building the quality digital infrastructure and the capacity, especially in developing nations, so these standards aren't just a luxury for rich countries.
Right, accessibility. And the other two?
Inclusion and connection. Inclusion means really broad participation, getting equal voices in the room when decisions are made. That's key for global buy-in.
Makes sense.
And connection is about engaging everyone, policymakers, developers, the actual users, to make sure the standards address real-world needs, not just theoretical problems cooked up in a lab. The big goal is stop duplicating effort and keep it grounded.
So it sounds like the standards organizations are trying to get their own house in order. But how does this global coordination translate down to the tech itself? Let's shift from the library to the deployment reality. We heard a lot about AI moving from the cloud to our devices' edge AI. Why is that shift so important globally?
It's fundamental, really, because the centralized cloud model hits physical limits with the sheer volume of data today. Think about the need to cut down latency and bandwidth issues.
Like with self-driving cars.
Perfect example. An autonomous vehicle is basically a rolling data center.
Yeah.
It can generate, 3 to 40 gigabits per second of sensor data every single day. If that car has to wait for a signal from a distant cloud server for every single decision, well, that latency could be fatal. Processing data locally, on the edge, cuts that delay to milliseconds, and it saves enormous amounts of bandwidth, which makes managing whole fleets actually feasible.
And that local processing often uses TinyML, right? That came up.
Exactly. Edge AI leans heavily on specialized hardware and techniques, like TinyML. You can think of TinyML as extreme constraint computing. Meaning you can run surprisingly complex machine learning models on tiny chips, maybe the size of a grain of rice, using just milliwatts of power.
Incredible.
And processing sensitive information locally, maybe voice commands for a healthcare assistant that drastically improves privacy. Plus, using these specialized AI processors is way more energy efficient than constantly sending data back and forth to power-hungry GPUs in a data center. Lower carbon footprint.
And what about reliability, especially, out in the field, away from good internet?
That's the other key bit. Offline capability. Edge AI makes it possible. It's absolutely mission critical for things that just cannot depend on constant connectivity. Think disaster response when networks are down, or, robots exploring deep space.
Can you give us a concrete example, something tackling a global challenge, maybe in a remote place?
Yeah, there was a great one discussed, the Mountain IBX device. They called it a digital watchman.
Okay.
It's this advanced IoT camera setup, but with the AI processing built right in, embedded. It runs on solar power, completely autonomous, and it doesn't use Wi-Fi or cell signals for constant connection. It acts as a LoRa gateway.
LoRa?
Yeah, it's a low-power, long-range communication standard, perfect for remote areas. It only uses satellite connectivity sparingly, just to send short, critical alerts when it detects something specific.
And what's it detecting? What alerts?
It's being used for critical environmental monitoring, spotting early signs of fire hazards in remote forests, sending warnings directly to authorities. And in precision agriculture, they're using it to detect the olive fruit fly, which is a major pest.
Wow. So real high-tech AI running on low power, solving real problems where there's barely any connection.
Exactly. It shows how these high-level standards can actually enable practical, low-power intelligence out in the real world.
That is practical intelligence making a difference. Okay, let's jump from the forests to maybe the most exciting and maybe slightly unsettling frontier tech discussed. Brain-computer interfaces, BCIs. The report details stuff that sounds straight out of science fiction.
It really does feel that way, but it's happening. I mean, the example of Rodrigo Hübner-Mendez. He mind-controlled a real Formula One car on an actual racetrack.
Mind-controlled how?
Using a non-invasive BCI, basically a cap that reads his brainwaves. Those signals were translated in real time into commands for steering, accelerating, braking. It's just an astonishing demonstration of human agency interacting with machines.
That's unbelievable. The precision needed for F1.
Okay, beyond the cool factor, how is BCI making a difference for social impact, for health?
The main focus there is on adaptive assistance, helping people. Olivier Wheelier's team, for example, they used their Prometheus BCI tech for the first ever mind-controlled torch relay at the Paris 2024 Olympics.
No way.
Yeah, it allowed someone with cognitive impairments to successfully control an exoskeleton arm holding the torch. The whole philosophy is building systems that adapt to the user's unique abilities and intentions, not forcing the user to adapt to some rigid machine.
That's incredibly powerful. But linking minds and machines like this, it must raise huge governance questions. If the tech is moving this fast, what are the specific ethical red flags for regulators, especially as BCI moves beyond medicine?
The big worry is definitely the spread of non-medical BCI. Consumer gadgets, gaming, maybe even workplace monitoring.
Employee monitoring,
Well,
wow. Exactly. That sets off serious alarm bells about cognitive freedom. The OECD, the International Economic Body, they've already flagged neural data, brain data as uniquely sensitive. The risk is eroding mental privacy, the potential for manipulation, or using that data coercively.
So if the OECD flagged it as uniquely sensitive, why aren't we seeing, outright bans instead of just talking about governance frameworks?
Well, partly because the potential benefits like that exoskeleton arm we just talked about are so transformative. You don't want to halt progress that could genuinely help people.
Right, the classic dilemma, speed versus safety.
Precisely.
Yeah.
So these governance frameworks, they're seen as the immediate, absolutely necessary step. We need to protect mental privacy and prevent misuse before BCI becomes commonplace. It just underlines why this whole global push for standards is so critical. The tech is fundamentally outpacing our shared societal grasp of what it all means. So what we saw today is that standards are really the essential common language. We need them to scale AI responsibly, whether that's coordinating, 700 existing standards in that new database, or managing energy use in specialized edge AI chips, or safeguarding mental privacy with something as advanced as BCI. The whole summit was about that shift, from abstract ideas to practical, measurable actions.
And that translation, that's always the hardest part, isn't it? Moving from principle to practice. But there was another complex challenge looming in these discussions, a really big security one. Managing agentic AI systems.
Yes, the agents.
Systems that can perceive, plan, remember, and act on their own without a human signing off on every single step. The panelists talked about a kind of failure point here. They called it the crisis of review.
Yeah, and that crisis comes directly from the speed these agents operate at. AI can generate outputs, make decisions, way faster and cheaper than any human equivalent.
Overwhelmingly fast.
Totally. It just swamps any meaningful human review capacity. But the accountability, legally and ethically, it still sits with the human who deployed the agent. If that human is just clicking approve without really understanding, that accountability becomes meaningless.
So the risk is misalignment. The agent does something unintended.
That's the core risk the panelists highlighted. People tend to treat these agents almost like employees you can just give a task to and let them run free. But that often leads to poorly defined goals, unexpected actions, and ultimately deployment failure.
Okay, so we have decision speed outpacing human oversight and accountability getting fuzzy. What's the one provocative thought then for us to chew on based on this specific challenge with agentic AI?
Well, the provocative idea that came up was this. If treating AI agents like unsupervised employees is failing, maybe we should fundamentally shift how we think about them. Maybe we should treat them more like regulated contractors.
Regulated contractors, what does that mean in practice?
It means they would be explicitly required, by design, to provide evidence that their autonomous actions comply with predefined safety specifications before they actually take the action.
So building the compliance checks into the process itself up front, not just trying to review the outcome after the fact.
Exactly. Defining the rigorous rules of compliance beforehand, embedding them in the agent's operational constraints, rather than relying on that impossible after-the-fact review.
That is a fascinating shift. Regulating the process, not just judging the result. Definitely something to mull over. Until our next deep dive.